Hello, my name is Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. In this Back to PowerBasics movie, we're going to create a logical partition and boot it up. I've just logged into the HMC. This is the welcome pane, so let's look at our systems, which we find in here. These are our 5 systems. We're going to create a logical partition on this machine here called Bronze. So 520. It has 2 logical partitions at the moment. This full system partition is really only used when we initially start up the box and it grabs all the resources so we can check what's actually inside the machine. Quite often people delete this. I've also got a Bronze VIO server here that's set up. Now both of these are not active, so we can ignore them for the moment. All the resources in the machine are available to us. Now if we want to create a new logical partition, we have to go to the server level, select which machine we want to create the logical partition on, and then we can take the operations configuration, create logical partition, and we can either create a VIO server or an AIX Linux logical partitions. Give it a name. Let's call it demo, so we'll remember what it's about. Profile name. This is more important in Power 4 days, but we can have different profiles with different resources in them. Look at dedicated CPUs first of all. Here we say how many whole CPUs we actually want to put into our logical partition. This 2 CPUs are given to this logical partition, and when it hasn't got anything to run on these 2 CPUs, it will run inside AIX the idle loop. It's actually a process called wait, and will waste compute power at that time. The minimum and maximum are constraints for dynamic changes to the logical partition if we as an operator want to change the number of CPUs wholly allocated to this logical partition. Now I don't recommend dedicated CPUs very much. I always tend to use the shared processing available to a logical partition because this is much more flexible and we make much better use of our resources. So let's look at shared. Here, instead of whole CPUs, we can talk to hundredths of a CPU once we're above a minimum of a 10% of a CPU or 0.1. So in here we could say the desired is to have 2 whole CPUs and the maximum is 2.5 CPUs, and we'll set a minimum of 1 CPU so that we won't start unless there's at least a whole CPU available to us. In later movies we'll look at some of these other functions in here about the which pool we're in, is uncapped or not, and its weight factor. Now we have to decide that we have these 2 CPUs. We have to decide how many CPUs we're actually going to use to provide that compute time. Well, of course, if we need 2 CPUs, we've got to have at least 2 CPUs up here, but we could say 3, for example, and a maximum of 4. This means that our 2 CPUs worth of CPU time can actually be spread out across 3 CPUs if necessary. This will allow us to peak over the 2 CPU worth of compute power, allowing this logical partition. Now we have memory, and again we have the desired. This is what we're actually at. Let's say 4 gigabytes for our partition, and want it to be able to, if we want to change this, take it up to 6 gigabytes. And this is far too low for a minimum. Let's say 1 gigabyte as a minimum. So we normally will get the 4 gigabytes. If the 4 gigabytes aren't available, it will allow us to go down to 1 gigabyte and be able to start a logical partition. But these 1 and 6 are normally only used for dynamic logical partition changes. Now our I/O resources here, I know that my disks are connected to this resource here. A T slot is actually built into the backplane of the machine, and a C slot is actually an adapter slot on the back of the machine. So this is at the built-in disk, so I want to select that, and we could, for example, pick up our Ethernet controller here. So select this. If I hit as required, it will fill in this column here. This means this logical partition can't start unless that device is actually ready. Alternative is desired, and we might use that, for example, for a CD drive. If it's available, we'll have it. If it's not available, we'll start anyway, and we can dynamically move that in if we actually need the CD drive. Now in this case, I'm not going to use a Ethernet controller in an actual adapter. So I'm going to use the HEA. So I'll clear that one, and we'll carry on. I'll show you that in a second. Virtual adapters. We're going to use real adapters for this simple logical partition. We'll come back to those in a different movie. We have two serial ports. These are used as a console connection via the HMC to actually talk to the logical partition as it's booting up and until we get it on the network. From then on, we tend to talk to our logical partitions over the network. And we'll carry on next. So here's our logical host Ethernet adapters. We have one of them in the machine, and it provides 4 different ports split between the port IDs and port groups. And so we'll select one that this first one I know is physically connected, and we'll configure that, which actual port we want. So I'll go for the first port on that first. That first connection. This is our virtualization actually implemented in the hardware here, so this will be a nice fast Ethernet port. We have other features here that we can add, and I'll just squeeze these on to the screen. And we actually recommend that all of these get clicked here. Now if we didn't know what these actually meant, we can click help. Okay, let me scroll these onto the screen. And we can say, well, what is enable connection monitoring? And we have a description here what that actually means. So the help system is quite nicely built and can help us out here. And we want to boot into normal mode. We'll look at the final panel, which is a summary. If we were designing this, not ad lib as I'm doing here, but from a spreadsheet of designing what our logical partition resources will be, we can use this as a final check that we got everything right. And we'll hit finish there to actually create our logical partition. We actually click on this machine. We'll now see we have a new logical partition here called demo. So let's start that up. First thing to do is to open a console window. Drag that on, here we are. Now it's not running at the moment, of course, so we've opened the console window, but we've not actually got anything to talk to. So let's activate this logical partition. And we only have one profile. We could have started a terminal window here by just clicking this and do it in one go. Let's go into advanced. I want to stop at the SMS phase of the boot up, so I can select the boot device. You can see it's gone to the running stage here. I'll bring back our console. It's saying hit 0 here to activate this as the console, so I just hit 0. You can see it there scanning through our resources to see what it can boot from. And we've gone into SMS mode here. If I hit going to go to boot options here, number 5, and I'll select our boot options, and then I'll say list me all devices. So it's saying here I could boot over the network, I could boot over a hard disk here. There's 2 hard disk possibilities in this logical partition, or a tape drive or a CD-ROM. And we'll boot this into AIX and install AIX in the next movie. The next movie is installing AIX from a CD.